Thank you so much, Sophie, and thank you, Jeffrey, for a great introduction and for setting the scene. So our first speaker today is Professor Lesley Hughes. Lesley is Distinguished Professor of Biology and Pro Vice Chancellor Research Integrity and Development at Macquarie University. She is former lead author on the Intergovernmental Panel on Climate Change's 4th and 5th assessments and a former Federal Climate Commissioner. She is a founding councillor with the Climate Council of Australia. Thank you so much, Lesley, for being with us. Over to you.
Thank you very much, Yvonne and Kaylin and Jeffrey and everyone for inviting me to speak with you today. I'll share my screen. Hope everybody can see a picture of a big bushfire, which will be featured quite prominently in today's talks, I feel. So I'm going to try and set the climate change scene, and I want to begin with this very important and now very famous statement from the Lancet in 2009, who stated that climate change is the biggest global health threat of the 21st century. I think most of us interested in this topic can remember the impact of that statement. Now, as Jeffrey has indicated, the IPCC's latest report summarising the physical basis of climate change was released in August with the tagline that climate change is widespread, rapid and intensifying. Antonio Guterres, who is the head of the UN, described it as code red for humanity. Mr. Guterres has a real way with words, and this particular description has resonated globally. Now, the report has over 1 million words and synthesized 14,000 papers. None of you want to read 1 million words. So what I'm going to try and do in my short section to open up these proceedings is to boil those 1 million words down to just a few of the key findings to set the scene. And the first two of these, that it's now unequivocal that human activities have warmed the atmosphere, the ocean and the land, causing widespread and rapid changes, and that the scale and pace of this change has almost no precedent in the 4.5 billion year history of this planet. We now have nearly 50% more CO2 in the atmosphere than at any time since the Industrial Revolution. It's the highest level for at least 2 million years and probably much longer than that. And the rate at which CO2 has increased over the last 20 years in the atmosphere is about 100 times the maximum rate of increase during the last ice age. The report from NASA that came out in June, which got a lot less publicity than the IPCC report, but was nonetheless extremely important, noted that the amount of heat trapped near the Earth's surface by the enhanced greenhouse gases has about doubled since 2005, and that the Earth has now warmed much faster than expected. It is now nearly 1.2 degrees above pre-industrial levels. I'm not going to show you many graphs, but I will show you this one from the IPCC report. It actually shows Earth's temperature over the last 2,000 years and indicates that over most of that time, the Earth was either very stable in temperature or cooling slightly. But come about 1850, warming really started to take off and has been going up extremely steeply ever since. Now, our oceans are absorbing more than 90% of this excess heat, for now at least, but we can now detect warming down to a depth of about 2 kilometres. The oceans are also absorbing much of the extra CO2 in the atmosphere, but unfortunately this is changing the composition of seawater, making it more acidic. And our oceans are now on average about 30% more acidic than they were in pre-industrial times. Third key finding of the IPCC report is the impacts of this change are accelerating. Here's an example of this with glaciers. So these two pictures were taken just 4 years apart in 2009 and 2013, and you can see what has happened over that 4-year period to the ice in that glacier. Our polar ice sheets are also losing ice at a great rate, both in the Arctic and the Antarctic, with the rate of loss quadrupling over the last decade compared to just back in the 1990s. Together, all of that extra water going into the oceans, plus the fact that warmer oceans take up more space than cooler oceans, means that sea level rise is also accelerating, with the rate of sea level rise about doubling in the previous decade compared to the average over the 4 decades before that. Our water cycle is intensifying, and what that means is that dry areas are getting drier, wet areas are getting wetter, and because a warmer atmosphere can hold more water vapor, and the atmosphere is holding a lot more heat energy, that means that when it does rain, the water comes down in more intense bursts, causing the sorts of flooding that we've seen here in the east coast of Australia very much over the last few weeks. Here's a picture of Australia and its rainfall over the last 4 decades, showing that the northwest of Australia and much of the west has been getting wetter. The southwest has been getting drier, as has just about the whole of the eastern half of the continent. The intensity and severity of our tropical cyclones are increasing, and there is serious consideration now of the need of a Category 6 cyclone. And probably most importantly for health, extreme heat and heat waves is increasing. 2020 was the hottest year on record globally, with the previous 7 years being the hottest 7. In Australia, 2019 was our hottest year, and Australia is now 1.44 degrees, as at the end of last year, above temperatures in 1910. In fact, in 2019, the number of extremely hot days was 3 times that of any year in the last century, with poor old Penrith in Western Sydney in January 2020 having this distinction of being the hottest place on Earth. The reason that this is so important is that in Australia, extreme heat and heat waves have killed more people than all other weather-related climatic extremes combined. Looking ahead, by 2050 or so, 50-degree days in our capital cities like Melbourne and Sydney could be quite commonplace. And for Western Sydney, the average days above 35 degrees could increase 5-fold by the end of this century. So we need to think about that very much in terms of our health systems. We all know that bushfire seasons are also lengthening and becoming more severe. In Australia, in some regions, bushfire seasons are now 2 months longer than they were in past decades. 2019 was not only our hottest year, it was also our driest, with rainfall 40% below average, setting up the perfect storm conditions for the so-called Black Summer bushfires. Black Summer, of course, is a misnomer. These bushfires started in July in late winter, but collectively going through to January 2020, they burnt more than 18 million hectares, which is 3 times the size of Tasmania. Now, there will be another talk shortly about the health impacts of those bushfires, so I won't go into this in any detail here, but I do want to point out that this series of bushfires is now known to be the costliest, the single costliest series of climatic events in Australian history, with quantifiable costs approaching $100 billion. Of course, many of the impacts of these bushfires cannot be quantified in terms of dollars. Coming back then to the key findings of the IPCC report, it's really important to realise that the worsening impacts of climate change are essentially baked into our climate system for at least the next 2 decades. What that means is if we were able to stop emitting CO2 and other greenhouse gases today, we will still get more warming. This is the only other graph I'm going to show you. Indeed, we're committed to further warming of somewhere between 0.2 and 0.6 of a degree from now because of the greenhouse gases that we've already emitted. This will commit globally the world to a rise to at least 1.3 to 1.7 degrees. And we are likely to exceed that 1.5 degree target that's in the Paris Climate Agreement by 2030, if not possibly even earlier than that. Fifthly, these projected changes in extremes are larger in frequency and intensity with every additional increment of warming. So what we can expect, at least for the next few decades until we turn that emissions curve down, is more severe heat waves and fires, more severe ecosystem impacts like coral bleaching, more floods, more droughts, more severe cyclones. Indeed, already 20 million people are displaced by extreme weather every year right now, and that will continue to increase. So it's those global impacts as well as the local impacts that we have to be aware of. Second last key finding is that unfortunately catastrophic events, sometimes called tipping points, cannot be ruled out because of our climate trajectory. These include things like the melting of permafrost, which puts a lot of CO2 and methane into the atmosphere, which is a positive feedback to climate. They include the loss of Arctic and glacial sea ice. They include the conversion of places like the Amazon from being a carbon sink to being a carbon source. And they include biological tipping points, such as the coral loss of coral reefs that we're already seeing underway even now. Finally, and this is the silver lining in the IPCC report. It's pretty hard to find a silver lining, but there is one there. The window for effective action is closing rapidly, but it has not yet closed, which means that our climate future from here on in, at least after the next couple of decades, is still in our hands. So I want to draw the parallel with how we deal with climate change, with how we deal with the other health crisis that already mentioned, which is that of the global pandemic from COVID-19. We have seen all over the world that the governments that have handled COVID better than others have actually done three things. They've listened to health experts, the science, they have acted early, doing things like closing borders, and they've prioritised the threat over all other activities. These are exactly the same three things that we need to do to handle climate change. Listen to the scientific experts, act early, we should have acted a long time ago, and prioritising the climate threat over everything else. If we had been doing that, those three things over the last few decades, we would be in a much better position now. So I want to finish with some statements here. We are in a climate emergency. It's not just a slogan, it is the reality, because we are seeing our physical and biological world transforming before our eyes. We don't have a lot of time to turn it around. It's what we do this decade, so between now and 2030, that will make all the difference for our future and our children's future. Every fraction of a degree matters, because every fraction of a degree of warming is doing us and everything else on the planet harm. Every year that we delay turning that emissions curve down is getting us closer to catastrophe. So every choice matters. You know, we have climate change with us because of billions and billions of poor choices. We have to start making billions and billions of much better ones. Thank you very much for listening. I hope that's been an okay introduction. I'll stop sharing my screen and pass back to Yvonne. Thanks, Yvonne.
Thank you so much, Lesley, for helping us understand climate change and its effects, and code red for humanity. And indeed, it should be code red for Australia as well.